Compilers are not the hardest kind of software to develop. The hardest kind of software to develop is real-time, high-performance, life-critical software controlling physical devices. Compilers break down into a front-end and back-end. The front-end takes in the source code, tokenizes it, parses the tokens, and generates an internal representation of the result, usually an abstract syntax tree. Challenges in the front end include meaningful error output and unambiguously parsing the input. For some languages this is easy. The BNF grammar for Pascal fits on a couple pages. Pascal's syntax in BNF notation contrasts this with C++, which is unbelievably difficult to parse. I see this as a major weakness of the language. Is their standard C++ grammar. The backend takes the abstract syntax tree and translates it to machine code that can be executed on the target architecture. Creating a basic backend is tedious but relatively simple. It becomes difficult when you start trying to optimize, especially with multiple dispatch, speculative execution, multiple cores, cache coherency. Correctly optimizing the output requires picayune review of the processor datasheet and a lot of analysis. Real-time, high-performance, life-critical software controlling physical devices is hard because real-time means you must have deterministic performance for all conditions. You do not want your jet plane's autopilot to behave erratically in the rain. Real-time plus physical devices mean you generally cannot use a breakpoint to debug the program. That CAT scan machine is going to keep pumping X-rays while you step into a function. High performance in this context means you are close to the limit of what the processor or bus can do. You are limited in the logging you can output without loading the system, such that it fails to achieve real-time. Life critical means that people may die if the software fails to perform. I worked at a Wall Street firm and, in hushed tones, they emphasized their software error rate had to be less than 1 in a million. Inappropriately I laughed. The last place I worked was on emergency radio communications systems, where we validated error rates to less than 1 in a billion. Physical devices exhibit all kinds of unexpected behavior. Stiction, mechanical resonance including subharmonics, wear, aging, temperature. Physical devices exhibit all kinds of unexpected behavior. Stiction, mechanical resonance including subharmonics, wear, aging, temperature.